Hello, physical science students. I hope you are all doing very well and welcome back from April break. On the CK12 reading that you're going to be seeing, it's going to be talking about the layers of the Earth. And you're going to get to this figure that looks pretty complicated here. Now, there's a key for it down here with all these different numbers, but I thought I'd go through a few of the distinctions so you don't get too confused. In reality, if you think of the layers of the Earth in terms of the core, the mantle, and then the crust on top, you'll be doing pretty good. But those are terms that are determined by the composition of the actual rocks themselves, or really the magma inside when you're talking about a place like the mantle. But you'll see some names like the astenosphere and the lithosphere thrown out there as well. The lithosphere and the astenosphere, these are distinctions made on the layers of the Earth based on what are called mechanical properties. So when you think of plate tectonics and the different way that the Earth's surface is broken up into plates, that includes the lithosphere, which in those plates ride on top of what's called the astenosphere here, which is kind of like a putty-like consistency. And this is the brittle part on top. That includes both the crust, but also a little bit of the top of the mantle as well. So when I talk about outer layers by composition, the difference between the crust and the mantle has to do a lot with density, because when the Earth went through differentiation, we know that the denser elements went into the center of the Earth and the lighter elements went out. So when you look at rocks that are consistent with what the crust is made of, you'll see things like granites, and they'll have lots of minerals like quartz, which is SiO2, essentially the same makeup as glass, and then feldspar, which has maybe a little bit of potassium and aluminum and is really a silicate mineral as well. And the nice thing about the density of rocks is that when you have rocks that are light colored, they're usually lighter. When you have ones that are darker, these are usually heavier, because those darker rocks that would be consistent with some mantle type rocks have a lot more minerals like olivine or the pyroxenes, these minerals that have both magnesium and iron in them, and they give them that dark color. So this is the difference between what crust type rocks versus mantle type rocks might look like. When I talk about outer layers by mechanical properties, we're talking about properties that emerge under stress. So how a substance reacts or deforms. So things that are in the lithosphere, these deform brittly. It means that they break. You create things like faults right here. Versus things that are in the astenosphere, in which all of our plates and plate tectonics ride upon, these deform ductily. So ductile deformation. That means that you get folds. So you can imagine when something's cold, it will want to break. Versus when something's hot, deeper in the crust, like the astenosphere, it's going to bend instead. So we can thank brittle deformation for much of the look of Maine's rocky coastline, because all these little cracks in these rocks, these are called joints. These are all made from when these rocks are put under stress in plate tectonics and mountain building events. And now, when these rocks break apart on the coastline to give us this look, these break along specific angles associated with that stress brittly. And you can see it over here as well. Thank you guys for listening. I hope you're doing well, and I hope this explains a few of the distinctions between the layers of the Earth.